It is Wednesday afternoon in the Midwest, which means another episode of Webinar Wednesday. This week, talking about process control, especially in an era of Industry 4.0. Now, believe it or not, the whole idea of industrial process control is a topic that is near and dear to my heart because for over 20 years of running manufacturing companies, every single one of those companies had an element of process control associated with manufacturing a quality product. So I spent time in the industrial space, I spent time in the coatings and finishing space, and process control was absolutely integral to running a successful business in that particular industry sector. So these are all the things. I know we're not supposed to use word clouds anymore, they're outdated, but the fact is that it's a great way to show you all of the different things that could affect the quality of a production part when I was in the metal finishing industry. Every single thing on here, from hole position on parts to the amount of powder that we were recycling to this customer specifications, our chemistry and our titrations, the amount of voltage we were putting into a coating tank, and so on, or into a powder coat booth, all of those things were elements that created effective process control. And if one or more of those were out of their action ranges, if one or more of those were out of control, it was really, really difficult to produce a quality part or to run our operations efficiently. Now, over all those years, I had some very acute reminders of how important process control is. Let me just give you a few examples. I got a call one day from the Department of Natural Resources saying they had been reviewing our exhaust opacity. If you don't know what that means, that's really the color of the exhaust coming out of your manufacturing plant. And is it too dark? Is it possible that there's too many particulates in that exhaust? And in that particular case, we had to rectify a problem very quickly. And that problem had been created by incomplete process control. Another example was when I was working with a Fortune 500 company, a manufacturing company everybody on this call would recognize. And we had a process control issue with one of our paint stripping operations that almost shut down their production line to where we could not get them enough parts for them to be able to run their line. Now, if you've spent time in that space, you know that for every hour that you shut down a major OEM, they can charge you $250,000 an hour for that line being down. And I had to live through that potential one time due to a lack of process control. I had another time when one of our technicians inadvertently released a plating tank to our wastewater treatment system and created a chelating situation that complexed heavy metals, in this case nickel, in a way that we couldn't separate it out of our waste treatment system. That was a plant that produced 1 million gallons a day of waste effluent. And all of a sudden, we couldn't treat any of that waste. We literally shut our manufacturing plant down for 4 days while we fixed that problem. I was working with one of the big three automakers, and we had a part that we had to produce for them. And if you're familiar with the idea of ppm, that is the parts per million, the number of parts out of a million parts produced that could be non-conforming or could be bad. So in that particular case, 7 parts per million were the number of parts that we were producing that were non-conforming, which means out of a million parts, 999,993 of them were good, 7 were bad. That was bad enough to where we almost lost a $2 million a year job, and we had to fix that problem using process control. How about salt spray test failures, where you put a part that has been plated in a salt fog machine, and you look at how many hours it takes for that part to start to rust? The test is more complex than that, but that's essentially what you're doing. We had situations where a part failed the salt spray and it had already been shipped. The order had already been shipped to the customer, running the risk that we would have to recall parts back into our operation. Those salt spray test failures in many cases were because of poor process control. Coatings thickness. I worked with a lot of paint and powder coat companies that would overcoat their products to make sure they were conforming. In one particular case, there was a powder coating company that was spending an extra $300,000 a year in excess powder to coat the parts they were producing. A very, very expensive issue, all tied back to poor process control. There was another time where I had to recharge an entire chemistry tank at a cost of $40,000. I walked into work one day and one of our chemical maintenance people said, yeah, we had to empty that tank and recharge it, refill it with chemistry. Cost us $40,000 that day that we weren't expecting to spend. There again, that problem resulted from poor process control. I love the example of the 1993 cryptosporidium outbreak in the city of Milwaukee. This was an outbreak that ended up in the municipal water supply and sickened 403,000 people in Milwaukee and the surrounding area. And if you recall that situation, it knocked the municipal water supply on its rear end for several days while they tried to figure out where this problem was coming from. And so many people got sick as a result of that. They ended up solving that by spending almost $500 million updating the process control and the infrastructure for the city of Milwaukee. And then there's this whole idea of holding tolerances on metal plated parts. Let me give you an example of that. On many of the parts that we plated for some of the largest companies in the United States, we had to hold tolerances of 2 to 4 ten thousandths of an inch, or as it looks on your screen, 0.0002 to 0.0004. And literally, the amount of plating that was on the surface of that part had to be within a range like that. So 1 inch looks like this. That's 100 thousandths. That's 10 thousandths. That's 1 thousandth. This is 1/10 or 1/10,000th of an inch. To put that into perspective, 200 what we call micro inches or 2 10,000ths of an inch is 10% the diameter of a human hair. And you can bet that holding tolerances like that required a tremendous amount of process control. Now, when we talk about process control and instrumentation, many of us think of a few key industries. We talk a lot about process control in the oil and gas and natural gas industry. So understanding controlling processes in the refinement of oil and the production of natural gas is really, really important. We understand process control in chemical blending and in chemistry. And I sold our last company to a chemical blending company out of Ohio. That process control in that operation was really, really important. We think about process control in pharmaceuticals, and certainly producing pharmaceuticals requires tremendous precision process control for all the reasons that are readily discernible to our audience. So those are the three markets that when we talk to technical colleges, community colleges, universities about process control, those are the three that come to mind. And I can't tell you how often we'll hear from somebody, well, we don't really have oil and gas or chemistry or pharmaceuticals in our district, so it's not important for us to teach process control. And I ask those folks, do you have industrial paint operations in your market? I bet you do. If you have a manufacturer that is painting or powder coating a part after they produce it, if you have contract metal finishers who are painting parts, I bet you have process control needs in that market. The same thing goes for e-coating or what we call electrocoating. If you have anybody performing e-coat operations in your market or in your district, that is really, really important when it comes to process control. Same thing for powder coating. Same thing as I just suggested for metal plating. The same exact thing for heat treating, where we're changing the properties of a part using heat treating operations. Process control is absolutely critical in that space. Industrial waste treatment. So as we are producing industrial waste from a die casting operation, from a metal plating operation, from another type of operation, that has to be treated. That is all process control. Municipal water treatment. Do you have a water treatment facility in your region or in your district that is producing drinking water for your citizens? Almost everybody does, unless you get your water out of a well. All of that municipal water treatment requires tremendous amounts of process control. Same thing for municipal sewage. So once we're done using that water, whether we shower in it, use it to cook our food or what have you, that goes back into the sewer. That has to be treated before it goes back to wherever it came from. So all of our municipal sewage operations require a ton of process control. And finally, any manufacturer that is in the world of food production or processing of food and the facilities that do that, all kinds of process control in those markets. When you look at the list on your screen, I would venture to guess that almost every single technical college and community college in the country has employers who are performing those types of operations. And as we've talked about today, doing process control well is absolutely critical to being successful in these types of economic sectors. That's why today's topic is so very important, is that when we get process control wrong, it's disastrous. When we get it right, it allows us to run efficiently. And so many different sectors of our economy utilize process control in their operations. So we're really, really excited to introduce today's topic. It's not just about process control, but process control in a smart technology era, in an industry 4.0 era. Our guest to talk about how we teach process control is my friend Jason Everett, whom we will introduce in just a minute, to talk about how we teach process control in an industry 4.0 era. So, Jason, it's a pleasure to have you back on Webinar Wednesday. Jason, as many of you know, is a great friend to ATS Lab Midwest, a great friend to Webinar Wednesday. He's a regional manager with Amatrol. Really, really sharp guy, degreed engineer. He earned his engineering degree at Purdue University in Indiana. He also holds a master's degree in business administration from Indiana University Southeast. And Jason has tremendous experience working in industry and now working on the education side of industry with a great partner like Amatrol. So Jason Everett, what a pleasure to have you on Webinar Wednesday. Welcome back.
Well, thanks a lot, Matt. I'm a big fan of Webinar Wednesday and the Tech Ed podcast. So thanks for having me.
We're excited to have you on board, and you always provide such great insights for our audience. I know they are equally excited to be hearing about this really, really important topic. Jason, I want to start out with this question. We're going to get into some of these aspects of process control as it relates to control systems, Industry 4.0, and so on. But for our audience members who may not be completely familiar with what process control is, what are those base technologies in process control, and how are each of these applied in the world of industry?
Okay, I think you did a great job identifying those industries that use process control, but process control is all about controlling, tuning, calibrating, and troubleshooting systems that move large volumes of product through the system. So mainly fluids and gases to create a finished product. You mentioned oil and gas, food and beverage, mining, paper mills, maybe up in the northern Wisconsin area, wastewater. I traveled through 15 states with Amatrol. I cover Florida, so I always say orange juice in Florida. I say beer in Milwaukee, and down here in the Louisville, Kentucky area, of course, across the river, it's in Kentucky. It's bourbon and a lot of process control and instrumentation in the bourbon processing also. So um, what technicians need to know as far as base technologies is that they need to monitor process variables. And when we're talking about process variables, there's five main process variables: level, flow, temperature, pressure, and analytical. And usually when we're talking about analytical, there's pH. There's more variables out there. There's an infinite number of variables. Those are the big five. So technicians need to know how to measure and control these different variables. The goal of any process system is to eliminate error. So there's always, with each one of the process variables, there's going to be a set point, a desired set point where we want the process to be at. And then there's going to be the variation in the process. And the goal of the technician is to eliminate the error or have it trend towards zero. And they do this through a process of tuning. And we're going to talk a little bit about tuning here in a little bit. But when you talk about more of the base technologies, you're talking about three components that make up the open loop and closed loop systems of process control. One are the field devices, then the controls and the control systems, and then the last one there is the actuators. So if you look at the common field devices, these are the sensors that are out measuring pressure, temperature, flow level through the system, flow meters, transmitters that are relaying information back to the controller. So all the field devices collect the information from the process, send that information to the control systems. And when we're talking about process control and control systems, there's three big control systems out there. There's PID controllers, PLC controllers, and then DCS control systems. So once the information is gathered from the field devices, sent to the control systems, then the control systems are going to make a decision how to adjust the system to eliminate the error. And they do that to manipulate, sending a signal to the actuators that in some cases, these are the control valves, the solenoids that are in the system. They're going to limit the flow, increase the flow, increase the temperature, decrease the temperature, or some of the examples of some changes they can make in the system. So, like you mentioned, uh, very slight variations in the process can have catastrophic consequences. You think about some tanks, when you're talking about tanks in oil and gas, some of these tanks are, millions of gallons. A variation of, 1% could cause that tank to overflow or, not operate properly. So very, very critical, the level of detail in this industry.
Absolutely critical. And shame on me for not recognizing that the brewing industry is so very important in the in the world of process control. Of course, a good Milwaukee, and I got my cryptosporidium example in there, but I failed to mention brewing and to your point, bourbon. So if the overarching point is that there are certainly plenty of industries where this technology is really really important, I think that's been heard loud and clear by our audience. You talk about these base technologies, Jason, level and flow and analytics and pressure and temperature. And in a lot of ways, those variables haven't really changed much in decades, if not even longer, in terms of how we control processes. On the other hand, as we start thinking about smart technology, smart devices and sensors, the advent and the advancement of Industry 4.0, we're starting to see process control and the way we monitor and maintain our processes change at lightning speed. Can you give our audience some examples of smart technology being used in process control? And then how can we prepare our students and our learners to work in these smart environments?
Yeah, that's a great question. I'm a big fan of Webinar Wednesday and the Tech Ed podcast, like I said before, and I know you mentioned Industry 4.0. A lot of the topics around Industry 4.0. A lot of the guests are talking about Industry 4.0, but mostly it's for durable goods. Cars, furniture, zero-turn mowers, things like that. But it's the same impact. Smart manufacturing industry 4.0 is having the same impact on the process industry also. So the communication protocols have increased and become more robust. As those have become more robust, so have the development of smart sensors and smart technology to capture that data at every step of the process in a plant. So smart sensors have increased their ability to diagnose faults prior to failure, to send push notifications to maintenance people or people in the plant to make adjustments. The connection to mobile devices, wireless networks are all part of the technologies that are being implemented into the modern process plant. So these organizations are like any other organization, they're starved for data. The more data they can get about the process, the more efficient it'll make the process, the better decisions they're going to make with the organization, and the more technology they're going to implement. So I think it's important for students to be aware of these technologies, to be aware of the protocols, the abilities of these new technologies, and to be on the lookout for them when they go into these modern plants.
So the technology is certainly revolutionizing what we call the device level or the edge level. So out in that edge computing, also revolutionizing the cloud level. I'm sorry, certainly the cloud level, but also the fog level. So our networks, our data servers inside of our plants, the control systems we're using to measure these smart sensors and smart devices and take action based upon what they're telling us. You had mentioned programmable logic controllers and PID controllers in a previous answer. I want you to expound on that just a little bit, Jason. When we think about the complex technology that goes into maintaining the precision process control that we have in industry and that leads to the repeatability of processes and ultimately to the quality of the product, the control system itself, whether it's a PLC, a PID control, is so critical to effective process control. What can you tell us about this control technology and what students and learners should understand about it?
Okay, yeah, like you mentioned, the three big control systems that we see in process industry: PID controllers, that stands for proportional integral derivative controllers; PLCs, programmable logic controllers; and DCS systems, distributed control systems. So we'll start with PIDs. So really simple to use. You see a lot of them out in industry, monitoring a single loop or a dual loop. Usually, that's their limitation. They don't get out beyond that. PLCs are a little bit more robust, can have make a little bit better decisions, have some expansion capabilities to add in new technologies, better communication protocol you can embed in PLCs, and then your DCS systems when you're talking about multiple processes within a plant all being ran by PID controllers or PLCs. This DCS system connects all those processes within a plant. So we're talking about big players in the industry. So the big players, the big name brands out there: Rosemont, Emerson, Honeywell, Indershauser, Siemens, Rockwell, just to name a few. So what students see out in industry, they're going to see everything like with manufacturing. They're going to see the old legacy PLC 5s, the Slick 500s, and then they're going to see the newest, latest, and greatest automation equipment. So really the big challenge is to train students on, or make the students familiar with the old legacy equipment, but then start training on the new, more robust control devices. And another challenge is just what control device to standardize your training on. You know, do you go with Honeywell? Do you go with Rosemont? Do you go with Emerson? Do you go with Indershauser? You know, and this really comes down to your local industry and what their needs are. I know when we talk about training, we usually talk about building blocks, those basic building blocks that form a foundation of a training program, and that's what we see when we talk to training programs out there. Is they usually start with the simple PID loops, single loop, dual loop, PID controllers, progress onto that into PLCs, and more robust systems progress onto that into DCS systems. So a lot of time is dedicated into these training programs on how to run these controllers.
Absolutely. And so we do the training on the controllers themselves, and regardless of which of those we're using, or for that matter, which of those brands that we are using. But none of these controllers, or for that matter, these individual processes exist in a vacuum, right? So whether it's level or flow, pressure, temperature, analytics, PID control, PLC control, and so on, none of these exist on their own. They are all completely networked. As those who joined us last week on Webinar Wednesday know, we had a number of individuals talk about the convergence of IT and OT, or the informational technology and the operations technology. And those are no longer separate departments within our plant, but they're becoming more and more overlapped in the way that we do things. And so that whole idea of networking and communications and interconnecting and networking all of this different technology that allows all of our sensors, all of our devices, all of our actuators to communicate in real time is really important as well, is it not? And so what is important, Jason, when it comes to networking and communications, and how we teach that aspect of process control?
So here again, there's a lot of legacy communication systems out there. You know, when we're talking about durable goods, you know, everybody's looking to standardize on Ethernet or Profinet protocol in manufacturing. But when you're talking about process industry, you know, you still see a lot of 4 by 20 milliamp signals out there, analog signals. Those have been around since the 1950s. So students need to be familiar with how that system works and how that communication works. Beyond that, you're looking at HART, and the HART communications stands for Highway Addressable Remote Transducer. So this is a very widely popular communication protocol in the process industry. So you have your versions of HART too. So HART's been around for a long time also. There's old HART, and there's new, modern, smart HART, wireless HART, HART 6, HART 7, on down the line. So there's a lot of different protocols out there. And then you have your digital networks: Foundation Field Bus, Profibus, provide two-way digital communication. Lots of advantages about using Profibus as opposed to some of the older legacy equipment. And then what we're seeing now, and I think you mentioned it before, is multi-protocol. coexistence. How do we have all these communication protocols coexist in a manufacturing plant? And that's really where the student needs to live. They need to be familiar with all and learn how these systems coexist.
Without question. And I know on that whole topic of coexisting and making sure that everything is working well together, one of the things that was really important in the time that I ran those process control driven manufacturing companies was this whole idea of tuning and calibration, to the point where ISO required that we had an entire process, an entire standard operating procedure for how we were going to make sure every single element of our process was calibrated. And it's not just enough to have that instrument in place, but we have to make sure that what it is measuring and the feedback that it's providing us is accurate. So when it comes to the idea of tuning and calibration, it's not just for regulatory compliance, but it's certainly important, but for quality system compliance and really just for effective process control. Tell us about tuning and calibration as it relates to process control. And if you have an example or two of ways that we can teach our learners that aspect of process control, that would be fantastic.
Okay. Well, I think you, in one of your examples to begin the webinar Wednesday, you mentioned the $40,000 fine. So, $40,000, that's a huge impact to an organization. So quality is always have an impact on profitability of the organization, and it's no different in process industry. So we'll start with calibration. And what we're talking about with calibration is all those field devices need to be calibrated. And when I talk about calibration, we're talking about how they, the current that they give off needs to be calibrated to zero, just like we calibrate a set of calipers to the set point prior to measuring a piece of wood or something like that. We want to measure each one of these control valves, solenoids, IP converters, so that when pressure comes in and it's at a zero level, or that it's going to give off a 4 milliamp signal if it's a 4 by milliamp communication device. And then when it's at the full 100% higher level, it's going to give off that 20 milliamp signal. So calibrating these field devices so that they give off accurate data when they're installed in the field is critical. And that's probably one of the areas that I see a lot of programs focusing more on tuning, and we'll get into tuning here in a little bit, and probably a little bit less on calibration. I know there's calibration engineers that's their full-time job, is to go out into the plant and calibrate all the systems, all the field devices in the system. Then there's also workers inside the plant that calibrate the systems before they go into the field. So calibration, setting those components to their set point, set zero point or whatever is very critical to process industry. And then you think about tuning, and we talked about PID. So tuning is the process of setting optimal gains for PID to get the ideal response of the control system. So this is all about tuning the system so that there's very slight variations using your controllers, your PID, your PLC, your DCS system, so that you eliminate the variation, the fluctuations, the error in the process. And this is, like I said, this has any kind of fluctuation has a huge impact on the process. A lot of training programs out there spend a lot of time on tuning their systems using those controllers. So.
But on this topic of tuning and calibration, Jason, two really, really important aspects or competencies of this whole idea of process control. And when it comes to those competencies and establishing that a learner or a candidate has those competencies, certifications are really, really important, are they not? Now, for those, again, that were on our webinar Wednesday last week, that Jim Wall, who is the executive director of the Smart Automation Certification Alliance, broke a little bit of news, actually quite a bit of news on the webinar about a new certification that he's working on relative to process control alongside one of those manufacturers that you mentioned earlier in our discussion. What can you tell about these new certifications that are coming down the pike for process control?
Yeah, I was actually on Webinar Wednesday last week, and I know it was a record number of attendees. So I hope I hope I don't let you down too much this week.
There's
But
still an opportunity for us to break the record. So
it's
let's
not
see
over yet,
how
right?
strong we can finish.
It's not over yet, right? Yeah. So certifications, matching those skills that are given to the student during a training program to skills needed in industry. Very, very important in manufacturing when we're talking about manufacturing of cars, trucks, durable goods. Same thing with process control and instrumentation. So there are some certification agencies out there. ISA, the International Society of Automation, has a certification for control systems technician. But really, I think the one that's really going to make a big impact, and like you said, Jim Wall mentioned this last week, is the Smart Automation Certification Alignments and their partnership with Indris Hauser, which is one of the leading control systems manufacturers in the process industry, to develop a framework for certifications for the process industry. So this is going to be at the specialist level. So it's going to be the middle skill technician level. And they're developing that framework to provide certifications for students in these training programs, but then also existing incumbent workers in the plant to give them upskill their skills.
So some great things coming from SACA, from the Smart Automation Certification Alliance, along the lines of certifications for process control. So we want our audience to keep their eyes open for those as we find great ways to establish that our individuals, our students, our learners have the competencies that industry is demanding when they get to the market. So speaking of demanding, Melissa, I know we have a demanding audience that has a lot of questions that have been teed up here over the course of our discussion. Probably have time for one or two. We're running a little bit long, but it's been such a robust discussion. Are there a couple questions that have come in that we want to address here on Webinar Wednesday?
Sure, thanks, Matt. So I think one of the questions, this is a really targeted subject area, but certainly something that we see a lot of growing and increasing demand for. We talked about all of the different career fields. So Matt or Jason, what are the employment prospects for somebody who goes through a process control program at maybe a technical college?
Go ahead, Jason, if you've got that.
Right. Like I mentioned before, I cover a 15 state territory with Amatrol. So a third of the U.S. basically is my territory. And I really don't see a whole lot of what they call E&I, electrical and instrumentation, or I&E, instrumentation and electrical, P-Tech programs are out there. They're few and far between. And is what I realize is that there's not a whole lot of opportunity for students to get into these programs, but the ones that do, there's a great opportunity for them to get an outstanding job, and I mean really high pay in these areas. So if you know some students that have really an attention to detail, because that's what it takes in this industry, very attention detail oriented person, a process tech would be a great career field for them to get in with a 2-year degree to get a great job in a lot of different areas. There's a lot of different industry needs. So.
Great, thank you. Matt, I think since we're over time here, I'll let you wrap things up for us.
All right. Well, thank you, Melissa. My thanks to Jason Everett from Amatrol. Did just a phenomenal job of walking us through this really, really important topic, which is how we teach process control in the era of Industry 4.0. The truth is we see these programs being taught in certainly the process control focused programs in our technical and community colleges. We're also starting to see it in automation and electromechanical technology, in industrial mechanics and industrial maintenance. So many different opportunities to teach these very important competencies for, as Jason Everett suggested, a great career pathway for those students that have those competencies as they're leaving their education program, or those already in industry who are eager to learn changing technology and new applications for process control. I want to thank everybody for being with us this week. We're going to be back again next week on Webinar Wednesday with a discussion from the University of Wisconsin Green Bay about a brand new engineering program that's in place and how that is supporting the employers in Northeast Wisconsin. So you won't want to miss that. We are here every single Wednesday at 2 o'clock Central, and we will see you next week.